Hello, welcome back to the topic Connect with Equations. Before we gone through linear equations, and here it's right time to consider power equations. So in this topic, we will consider equations that are not linear, but I'm not going to concern quadratic equations. They're a specific topic and basically set aside for a while. So right now, I just consider non-linear equations in the form x to the power n equals k. So basically where n is more or equal to. So basically it might be n equals 2. In this case we'll have x squared equals k. It might be n equals 3, so we'll have sort of cubic equation, right? But this is a basic equation where you have variable and it's split up between, like it's separated from the number. So k is sort of a number. For example, in given case, k might be 3. Let's say in this case it might be, let's say, -5. So k can take any number. It might be not necessarily an integer, just any real number. So you can say k is from real numbers. It might be also integers, no matter. So in this case, you understand that we typically need to have a general approach how to solve them, and I'll give you shortcuts. So it's easier because if you remember what stays for the power, if you just remember topics of indices, this is about index, so this is index form. So you can figure out that you can, if it's equal to some number k, you can figure out x value as nth root of k. Why? Because here on the left side you'll get, if you apply nth root for both parts, so obviously according to the power rule, because nth root of some number x, let's say, it's x to the power 1 over n. And if you apply it here to x to the power n and apply this nth root, you'll basically get this, right? And according to powers rule, you just need to multiply n by 1 over n. So that finally n will be cancelled and you're left with x to the power 1. So that's the most efficient way how you can solve. Because you can guess, like for example, in this case, x squared equals 16, you can guess that one of the value for x is 4. Okay, now pay attention to what might be, like, what details might be here. So we need to consider n as even and n as odd number. For example, we consider n powers that can be only integers, so we don't care about other interim numbers like decimals, rational numbers. Instead of n, we just only consider n as integers. So that's why two categories might be here within this equation. It means that if n is even, like with the example x squared equals 16, obviously one of the solution, if you apply this methodology, is x equals square root of 16, which is 4. However, it's only one possible solution, because generally, if you put -4 and square it up, by definition you'll get -4 times itself. So 2 minus during multiplication will disappear. It means they kill each other, and you'll get also 16. So you arrive back to the right side of the equality. So that's why x equals -4 is also eligible. So general case, when n is even and you have x to the power n when n is even equals k, so the general solution should look like plus or minus nth root out of k. This is the typical one. When n is odd, like in the case x cubed equals 27, In this case, you apply the same approach. You take in the cubic root out of 27, you'll get finally 3. If you want to say that it might be negative, let's check it. It might be also possible to have negative 3 as a solution. Okay, let's see. So negative 3 cubed is simply negative 3 times itself and times itself again. So 2 minuses will disappear. However, there will be 1 left out. So that means negative 27. But because you have positive 27, negative solution doesn't work. So that's why from here I can set up the general rule that if n is odd, in this case, we have a general solution as just n's root out of k without plus minus. That's it. This is the typical one. Okay, I can also prove why actually you take in plus and minus in a bit more scientific way. For example, I considered that one, x squared equals 16. In this case, your n2 is even. So what we can do? We can try to set up 16 and transfer to left side as 4 squared. So trying just to imagine that 16 is sort of a square number, right? And that's why we're eligible to put 4 squared. So once we transfer, we get 0. And now remember the formula about the difference of 2 squares. What it tells us? So it tells us that it's a minus b and a plus b. And because the resultant value is 0, so each factor might be 0. In our case, a is just x and b is just 4. So it turns out to be that instead of a squared, we just simply get x squared. So according to the formula, we have x minus, so instead of b we have 4, so that's why we have x minus 4 times x plus 4. And the result is 0. So what we can do, we can simply say that each factor might be 0, so x minus 4 is 0, or x plus 4 equals 0. So in this case, we can figure out that one solution is 4, and the second solution is negative 4. As you understand, in case of even, like as we considered here, 2 possible solutions. So absolutely, it means without taking into account the sign, they are the same, 4 and 4. However, just one is the only difference is that one is negative and one is positive. So just go back to the general pattern and consider this as the final formula. Or just use, difference of the square. However, the power might be a bit more, like not 2, maybe 4, maybe 6. So in this case, it's better to apply just ready-to-use formula. So in case if it's odd, just apply this formula as if just you have only one solution, which is n's root out of k. And keep in mind that n's root out of k is always k to the power 1 over n according to index formula. This topic related to indices. Okay, so let's maybe figure out several values, what we can do. So the first example, when we have x squared, let's say equals maybe, let's say 13. So I'll just intentionally take no square number. What we can do, just by definition, we take the nth root, in this case it's square root, out of 13, and we put plus minus according to the formula, right? According to this formula. So that's why we simply can say that if we take calculator, we can figure out the value, but for sure it's going to be plus minus 361 to 2 decimal place. That's how it works. Okay, why we're eligible to evaluate square root out of 13? Because 13 is positive number. So obviously, because we have x squared or x in even powers, the right side should be positive. So that's why, for this reason, I'll give you a counterexample. For example, what if x squared equals negative 4? In this case, you're not able to take the square root of negative 4 because under the root of even powers, power is 2 imaginary, but we don't write, you cannot take from negative number. And look indeed why it doesn't work, why we don't have any solution. So actually, as x is not equal to that, so no solutions. Or you can set up the empty space for x as solution. So I try to prove why we're not able to take square root of negative 4, or basically why that equation doesn't have any solution. So what if we transfer negative 4 to the left side? We'll get x squared plus 4 equals 0. So it turns out to be that the minimum value for x is just 0, because it cannot be negative, so this part is always positive, or a 0 at least. So that's why if we add on top of that positive number 4, we definitely never reach 0. So it never be equal to 0. And hence, no matter what x is, there will be no solution. That means there will be no way to get 0. So x is just empty set. So it means no solution at all. Alright? So let's take example with odd powers. X cubed, let's say, equals to 30. Okay, in this case, we just simply take the cubic root out of 30, and if you have calculator, you just figure out that. Okay, what if we have fractional or proportion-like equations? For example, this one, say x over, example 4, x over 5 equals 3 over x. How to cope with that? So normally you just remember how we struggled with fractional equations. That was actually in the linear equations section. However, this, as you understand, not actually linear. And there, in the previous videos relating to fractional or proportion types equation or proportion-like equations, I put a stress on this fact, that indeed that's actually non-linear equation. However, I just used an efficient way and a shortcut to make sure you understand how it works. If not, just go back to that video and try to watch the game. So, however, here I'll just use a crisscross way. I just multiply crisscross, and I'll figure out that I'll have x squared equals 5 times 3 is 15. And now I get normal power equation. So, because we have power of 2. In this case, we resolve as plus minus square root of 15. Okay, that's how it works. So probably I'll give you one more when we have, let's say, something that don't have solution. Let's say x over 7 equals negative 2 over x. So we do the same because it's fractional one, we crisscross, and we'll get x times x is x squared, and we'll get negative 14. In this case, in order to find x, we understand that x squared should be more equal than 0. However, the right side doesn't tell us that. So what to do in this case? Just simply say that we have an empty set of solution. Empty set or just specific sign. So no solution. So hope you enjoy. I think that's enough for explanation. This is the easiest topic. So make sure you understand that the logic is pretty straightforward, and don't forget to recap index topic if you just forget how to cope with indices. But in this case, it's really, one more time, it's really straightforward. Hope you enjoyed. Don't forget to subscribe. Your Daniel Dallas. See you later.